Okay, so I have been getting a lot of questions recently about quantum theory and quantum numbers, honestly more so the numbers. So I'm going to just quickly explain the theory behind the numbers and then go more into detail about the numbers. And if you guys are still struggling, either ask specific questions in the comments or in our tutoring sessions, let me know and I can even give some practice problems. Okay, so quantum theory is just the theory that energy has wavelength particle duality. So the main thing that you guys are learning about for energy and the quantum theory that goes with it is light. So I'm going to mention photons, which are kind of the particle form for light energy. So photons, like I just said, are a quantum of light. Quantum is just like a packet, basically, so a packet of energy specifically for light. The plural of this would be quanta. So basically what this means is that a packet or photon is detected when you look at these things via different technology, but when it actually travels, it travels as a wave, so that's how it has particle and wave duality. So to kind of show you guys a picture of some of this, I couldn't find a good picture of a photon in packet form, but I could find these. So you're going to need to know all the different stuff for the waves, more so than the particle. The most important parts of it that are wave-like is the fact that it has wavelength and frequency, which you can kind of see here. So wavelength is just measuring crest to crest, so if I kind of draw on that for you guys. So it would be from here to here. That is a wavelength. Fun fact with this, normally it'll be in meters. However, on the exam, he may give you nanometers, in which case 1 nanometer equals 10 to the negative 9th meters. So it's just a conversion factor. That's relatively easy. And then over here, I'm kind of showing you how it works with light, because there are a lot of different types of energy and stuff, but only this little sliver right here is actually visible to us, and it has to do with wavelength itself. So if you look down here at what I just circled, which I accidentally crossed out a little bit, but it's okay. So basically, there's certain wavelengths that are visible. The other wavelengths our eyes are not able to see. Okay, I think we're pretty good on that though. So there are 4 quantum numbers: N, L, ML, and MS. So N is just the principal quantum number. It's definitely the most important, hence why it's normally first with any kind of order during lectures or this video. Basically, it is just how many electrons it can hold. So shells are kind of similar to shelves. So what I mean by that is if you have, let me draw it out here for you guys, is if you have lithium that has 3 protons, thus 3 electrons, because unless it's an ion, electron number and proton number match each other. So it has 3 electrons. However, electrons can't just be kind of floating wherever they want like that. No, it can't be like that. There has to be something holding those electrons in place, and that's where the shells come in. So basically, for lithium, you would have 2 shells. For something like this, it would be written as just N equals 2. So basically how this works is, since this is the nucleus here, you put electron here, and then just an electron kind of wherever on this one. Now you might be wondering, well, why can't we just put all 3 on this guy here, that inner shell? So the reason for that actually has to do with this. So I'll kind of scroll down and let you guys see a little bit better than you could before. So to determine how many electrons can be held in a shell, you have to take 2n squared. So basically, as I said, this is n equals 2. The reason it's n equals 2 is this one here, this outer one, is the 2. So basically, you start from inner and work your way out. So 1, 2, 3, so on. Because of that, this would be 2n squared, 2 times 1 squared is just 2, so only 2 electrons can be held in that first shell, and it'll always be like that. That and something very important to note for you guys is that N is actually determined by a row on the periodic table. So basically lithium is in the second row, so it has 2 shells. After this we have L, which is basically the orbital, or more scientifically named, the angular momentum. So down here I'll kind of draw a little bit more. So L is always 1 minus N. So basically what that means is if you're talking about something that only has 1 shell, so is either hydrogen or helium, because it has either 1 or 2 electrons, then L would equal 1 minus 1, which is 0. So basically what that means is if L equals 0, L equals 1, or L equals 2, it determines the shape. So for 0, the shape of the orbital is just this. It's just a weird little circle. If L equals 1, however, it's a dumbbell shape. If L equals 2, this is where it gets a little bit trickier. So for the first one, I always just think of it as L equals 0. 0 is basically the shape you want it. Versus if L equals 1 and is in the p orbital, so n equals 2, then it'll be dumbbell shaped. So how I remember the second one is basically, since it's going from 0 to 1, for 1, just think that you're adding the 2 s's together to get like this little dumbbell shape. And similar can honestly be said for L equals 2 and L equals 3. So basically for L equals 2, it'll be like a little clover leaf type shape. So it'll be kind of like that. Basically for each one, you're just adding the last shape. So for this, for L equals 1, you're just adding 2 of the S shapes. And then you're adding 2 of the dumbbell shapes here. For L equals 3, you're again just adding shapes. So you start off with the dumbbell, or like the double dumbbell. The only difference is this time you just add 1 more dumbbell. So it would be like that. And this would be for the F orbitals. So the important thing to note with angular momentum is just knowing how to draw the shapes. Like if on the exam you said, draw the orbital for L equals 2, you have to be able to know that's just a little clover leaf shape. So that I can actually show you guys here, so it's less poorly drawn, so it will be like this. Okay, so, and then the next thing to remember with this is L is 1 minus N. So that's how you know that it's for S orbital, P orbital, D, or F. After this, we have magnetic quantum number, or orientation. So orientation is probably the hardest out of all of them. So basically, whenever you're doing orientation, you have 3 axes. So you have Y, you have Z, and you have X. So let's stick to the easier shape. Let's go with L equals 1 or a p orbital. So I'll do this in blue, this first one. So there's basically 3 different orientations, because orientations go anywhere from negative L to positive L. So I know you guys are probably like, well, what the hell does that mean? So a p orbital, L equals 1, and it's dumbbell shaped. So basically, if this has to go from negative L to positive L, it has to go from negative 1 all the way to positive 1. However, you can't just have -1 and +1, there then also has to be 0. This means that there are 3 different orientations possible. So I'm going to explain how. So orientation 1 is along the x-axis, which would be p with a subscript of x. Then there would be the one along the y-axis, which I'll do in red. So p, and then I'll do y. Go back and do x, or px. And then the last one, which I'll do in green, would be along the z-axis. So it would be like this. So there's 3 different orientations or ways that it can like face you, you could almost think, for something that has L equal to 1. Which brings us to the last one, which is MS or spin. This one is literally just called spin, and it's probably the easiest out of all of them. So spin relates to electrons. So I know you guys have already learned that like electrons will be arranged with little arrows that kind of look like this. So that relates to this. So basically, MS as a quantum number is saying that each electron has a charge of either positive or negative, but it's not a positive or -1, it's a positive or -1/2. So basically, if you say a -1/2, then it's spinning, then it has a down spin, which I'm just going to negate here with a little down arrow. And if it's +1/2, that means it has an up spin. And that's literally it for spin. You just have to know that it's always going to be 1/2. Up is positive, down is negative. And honestly, the best way to remember that one is just think back to algebra, or really a lot of math classes. Anything where you have had to graph, when you're on the y-axis, anything above 0 is positive, anything below 0 is negative. So I believe this is everything that you guys need to know for quantum numbers and quantum theory. If you have any questions, concerns, or comments, put it in the comment section. Have a good rest of your day, guys.